Alright, we're back over here. Okay, so there's our gear assembly. Make sure it all works like it's supposed to. It's nice and hard now. There you go. That's how you want it to work. Okay, so this part here is done for now. We'll do a final check again later, but after we put together, you always do a final check. Okay, so now this all has to go over here. And we got to rivet this all together now. So I got to determine my back height right now, which is the depth of this in here. So it's in there pretty deep. So you want to have this rivet sticking up high enough that this here will push on the rivet into the hub bay. It'll have the rivet tied up underneath the into the back side of the basket, not a big gap in there. If you have a gap in there, when you collapse this rivet down here, all of the shank has to squeeze into underneath the rivet head to squeeze it to make it tight. Well, that's not going to happen, probably. So we got to make sure it's the right depth. It's not just a matter of beating this down further, because when you put pressure on, if you can move it by beating on it, when you put pressure on it, it's just going to move anyway. So you have to actually cut these rivets, or these dowels, shorter or taller as needed, which is kind of a pain in the butt, really. Turn that on helps. Okay, it's about 41 right there. Measure it 3 or 4 times to get a consistent number would be nice. $41. And then we come over here and measure this one. $14. I doubt that. Now it's 9. Yeah, can't see what I'm doing, can you? So it's 14. And we were 40, wasn't it? 41. 51 that time, but 41. Yeah, the best way of measuring this is you measure it this way. 31. 73. That's the most accurate way of doing it. It's 42,000. Okay, so this sticks up way higher than we need, so that means that we'll be putting pressure on this rivet head. Definitely will have pressure on it. So that rivet can actually be a little bit shorter. And I have one right here that's cut different, but I don't know if it's shorter or taller or the same. So either way, it doesn't really matter. As long as it's taller than you need, you're all right. If it's, it'll work. I forget how I do all these, but basically the rivets need to go into the hole right now. That's not going to work. I'm going to do something different here. So this is made for doing early stuff. So have I done a late one yet? It looks like I have not, because these tools do not line up for this application. Yeah, this does not fit this. So I have yet to make one for this application, which means we're going to have a serious time lag involved here. I got to make new tools. Alright, or I got to come up with something else. Looks like I have not made tools for this. This is all for 900 motors, not 7,000 motors. Okay, so What are we going to do about this problem? Good question. There's no easy fix. Everything looks bent. It is, it's warped. It's cup shaped. I see the light in there. It's bowed up. Nice. Let's see here. Things are completely different. Alright, be back. I gotta think of something. Okay, I'm gonna have to make this tool from scratch. There's no way of getting around it. So here's my tool I made for going in there, so that works fine for centering that. But this piece here I gotta remake. So it's not really that hard to do, I just gotta figure out some dimensions. This dowel pin's on center with this one, so the ram pushes directly on top of the rivet head. It's all set to the center of the hub, whatever the bolt circle is, which is the rivet circle. It'll be half whatever that is. You measure that, and half of that is your offset distance. That way this here centers this part here. So when this is on top of this, this here will center into that. And we get it right in the right spot. There. Now that piece is centered. When it goes on this dowel pin, it will offset over the correct amount so that the rivet machine will push directly on top of this rivet. If you don't push directly on top of the rivet, when you crush a rivet, it will fold over on yourself and be all screwed up. You want to push straight down with it. That way it goes down where it belongs. So I need to make a new backup tool. So that's what we're going to have to do. And seeing how it's already tomorrow, because it's past midnight, it's a great time to find these problems. Okay, so what I did was I grabbed a few baskets. So this is an early basket. This is 71 to mid 75s, mid 70s, somewhere in that area. Somewhere in the later 70s, they put this reinforcement ring on here because these used to warp. Probably when they updated the clutch in 74, midway through 74, they changed a lot of stuff. That's probably when they updated it, would be my guess. This is a 71A. A is modified. That would be a modification. They're 100% interchangeable, just different. So this one here has the kicker ratchet already riveted in. So what I got to do is I got to get one without the rivets in there so I can measure the holes accurately. This one's no good, so I cannot use it as a sample. I have to measure what the rivet diameter is on this. So this one here is a broken one, so it's a good one to cut all this off and see what we have. Okay, I got to stack more different ones here. Some are the same, some aren't. So this here is the same as this one. Here's another one. This one here is electric only. See, there's no ratcheting on it. I need to measure this diameters on this stuff to see what we got. See how this one looks bigger? Okay, this one here is a 79. 79 is when they put the extra lip on there. See how this is recessed? This one sticks out. So they made a little bit of change in the offset of where the clutch is inside the motor. They're pretty much interchangeable, but there are some, it changes where this was at a little bit. So even though they still ran the early starter motor, they screwed on with this. They also played around with the clutch gear on the inside, the spacer in there, and that probably has something to do with this. But anyway, there's a change in there. So I got to measure this to make sure they're all the same. There's another late one here, and here is another early one. So all of these I got to measure to get the idea of the offset from this surface down for a height. See if they're all the same. And then I got to see about the diameter of this because this piece has to recess over this. And it'd be nice if it's centered off of that so the rivets would be identical on every one. Now, if we have the dowel off of this, this is coming off your bearing. So you got a little bit of clearance in the bearing, but not very far. So technically, this could just be a clearance cut. Probably won't matter. We just let it center off the bearing. We're gonna have a little bit of clearance in this, but that's not gonna be enough to really bother it. But there is some clearance in there, see? It moves around a little side to side. There's probably at least 10 thou movement in that. That's not enough to really hurt the kicker mechanism, but you know, whatever. So I got to measure all of these baskets, see what they are. So I got my deep calipers here, so I can measure down in there deep the diameter. So this is a 8-inch caliper set, or a 12-inch, or whatever the hell this thing is. This is a 12-inch set. So that means I can measure 12 inches if it had a battery in it that worked. So the battery don't work. That means the battery's no good. Alright, I'm going to find me a battery. I think I got an extra one. We'll be back. Alright, we're back. Batteries work now. Dead battery. 0, 0, 0. Okay, now I get to measure what we got here. So first we're going to measure this guy's here. Looks like we're just under 3-inch. Yep, about the same. Okay, I'm going to measure these other ones. This one's a little over 3. About 303. Here, 95, 96, 97, 3, 301. 301. 298, 99 in a place. 97. So it looks like 302 is about the biggest thing I've found so far. So if I make it 3-inch 5/1000, it should fit over all of these without a problem. So that's the bore size I need to make it to. That'll give me 5 thou tolerance. Alright, so 3-inch 5/1000. And I need a piece of metal that's at least this big around, which is 4 inches. That'd be bare minimum, preferably a little bit bigger than that. That's a big chunk of metal. And then we need a depth all the way to here, across whatever the height this thing is. Let's grab this right here. Just a rough indicator, not super accurate, but about 2 1/4, a little above probably. Oh, we don't have to measure right in the center. You're a dumbass. Just learn how to do your job. 2.222. 2.2 inches. I wonder if it varies. Great. 2.230. 2.207. 2.16. 2.22. 218, 210. So 230 is our deepest one. And that's not counting the outer lip, that was the inner lip. There's another step up here with a few thou. You know, 20 thousandths. I think I'm stupid. Another 17 thou. Great, another 20 onto that. So that means we need to be 230-ish plus another 20, 250. So a quarter. 2.250 is a quarter inch. That looks like that's the minimum height we need to be. 2 1/4. This one's 150. A lot higher than this. Okay, so we need a piece of metal that's 2 1/4 inches tall. That's at least 4 inches diameter. Preferably a little bigger. So I'm sure we got that just laying around anywhere, right? Alright, so let's go look at our metal department. I doubt we're going to have anything here tonight. We could use a piece of aluminum, I guess would work. Don't really like using aluminum for stuff like this though, it's not that strong. I like strong. So I got my metal ingots up here, but they're no, I already know they're not 4 inches in diameter. Nope. But they are 2 1/4 tall. There we go. You know, these are 1144 steel, which cuts really nice. It's very strong. Almost makes it. So if I cheat and offset bore it, I can make that work. And that's how big? It's 2 1/2 inches tall. So by the time I true it up, it'll be 2 1/4. So if I offset it over, I can at least get to what I need. Yeah, we can cheat and do an offset because all the pressure's on the one side. It doesn't really matter. It can even be open on the back side. It wouldn't really hurt it. But that makes it hard to machine. I have to do it in the boring bar. I have to do it up in here in that machine right there. I can't do it in the easy machine over there, which is called a lathe, which is where it'd be easy to do this kind of work. Easy tools, can't use. Unless I find some bigger metal. So I'll have to look at the old machine shop at home. The old shop. See if we got something there. Doubt it. That's a pretty big chunk of metal. Maybe. Don't know. Let's see. Here's some more stuff over here. Oh, same pieces. Yeah. Just more of the same. Equalizing the weight of machinery around here. We need more weight on that corner. Okay, so I need 2 1/4 inches tall and at least 4 inches diameter. Looks like this is about 3 3/4, just over. Be a lot easier to do this in a lathe if I had a full piece. Doing the milling machine is going to be time consuming and long. Not quite as accurate either. Alright, I think that's about it for tonight. We have run out of material to make tools from. So I'll do it tomorrow. Oh, and it's only 12:30. Oh, we're getting out of early tonight. Alright, see, even I run out of stuff. That's it for tonight. We are done.